All right, let's take a look at Unit 3, Activity 3. So in Unit 1, we explored the conservation of mass. Give an example of the conservation of mass and describe what that means. So the conservation of mass was where the sum of the mass of the reactants equals the sum of the mass of the products. So if I have 1 gram of aluminum combining with 0.5 grams of oxygen gas in the air to make aluminum oxide, then I should have 1.5 grams of aluminum oxide created because the sum of the mass of the reactants would equal the sum of the mass of the products. So describe what the conservation of mass means. Well, matter can't be created nor destroyed. Let's look at number 2. In Unit 2, we explored compounds and chemical formulas. Give an example of a chemical formula, then describe what information a chemical formula provides, including what the subscripts in a chemical formula tell you. So why don't I use my Al2O3? That's a compound and its chemical formula. That's aluminum oxide. This is telling us that we have 2 aluminum atoms combining with 3 oxygen atoms. So the subscript 2 on the aluminum tells us how many atoms of aluminum we have, and the subscript 3 on the oxygen tells us how many oxygen atoms we have. Let's go on to question number 3. In this activity, we're going to explore the use of coefficients. Give an example of a coefficient. So let's think about how coefficients are used in math. So coefficients are used to balance things. What I mean by that is if I have aluminum combining with oxygen to give me aluminum oxide, you'll notice that I have 2 oxygens on the reactant side, and I have 3 oxygen on the product side. And if I want to follow the law of conservation of mass, I have to put a number in front to multiply the 2 and the 3 to give me 6. So I have the same number on each side. So this would be an example of a coefficient in front of O2, and so would this be an example. And then I have 4 aluminums, and that 4 is another coefficient. So the 4, the 3, and the 2 are coefficients that are used to balance out the number of atoms on the reactant and the product side, so I'm actually following the law of conservation of mass. Now, we don't have model kits with us, which is fine. We're going to go on to the reaction data and observations, and we're going to practice balancing equations, which is where we are following the law of conservation of mass. So here you will notice I have a reactant side, and I have a product side. I have 2 hydrogen on the reactant side, 2 hydrogen on the product side. I have 2 oxygen on the reactant side, but 1 on the product side. So I'm going to put a 2 in front of H2O. You can't change the subscript because that would change the substance. This 2 gets distributed to each element in the compound after it. So now I've balanced my oxygen. I can put a 1 in front of O2. But now this 2 gets multiplied by the subscript 2 on the hydrogen to give me 4 hydrogen on the product side, which means I need a 2 in front of the H2 to multiply to give me 4 on the reactant side as well. My coefficients are 2, 1, 2, and I am now balanced. Let's take a look at question number 2. So I have 2 hydrogen on the reactant side and 1 on the product side. So I'm going to put a 2 in front of HCl to balance my hydrogen. Then I have 2 chlorine on the reactant side. I already put a 2 on the product side in front of HCl to balance the hydrogens, which also conveniently balanced my chlorine. I can put a 1 in front of H2 and Cl2. I have the same number of each atom, each type of atom on each side, so that means I am done. My coefficients are 1, 1, 2. Let's look at number 3. I have 2 sodium on the product side, but only 1 sodium on the reactant side. So I can put a 2 in front of sodium to balance it. Then I'll notice there's 2 oxygen on the reactant side, but only 1 oxygen on the product side. So to balance this oxygen with this one, put a 2 in front of Na2O to balance the oxygen, which has now changed the number of sodium that I have. So I need to change the coefficient on the sodium to a 4 to balance it with a 4 sodium on the product side. Put a 1 in front of O2, my coefficients are 4, 1, 2. Let's look at number 4. I have 2 nitrogen on the reactant side and 1 on the product side. So I'm going to put a 2 in front of NH3 to balance the nitrogen. Then I notice 2 hydrogen on the reactant side, but I have 6 hydrogen on the product side because 2 times 3 gives me 6. Since I have 2 hydrogen here, if I put a 3 coefficient in front of it, 3 times 2 will also give me 6 hydrogen. So I put a 1 in front of the N2 because it's already balanced, and my coefficients are 1, 3, 2. Number 5. I have a carbon on each side, 4 hydrogen on the left side, 2 on the right. So let's put a 2 in front of H2O because 2 times 2 would give me 4 hydrogen. Now, when you have pure oxygen or something in elemental form, you want to balance this last. It will just help you a lot if you do that. So what I'm going to do here is I'm going to go ahead and add up all of the oxygen that are on the product side because I have oxygen split in 2 different compounds. You have 2 oxygen here and 2 oxygen here. So 2 plus 2 would give me 4 oxygen on the product side. So I'm going to put a 2 in front of O2 because 2 times 2 is 4. And now everything is balanced and we're done. The coefficients are 1, 2, 1, 2. Let's look at number 6. I have a nitrogen on each side. And I have 2 oxygen here on the product side, but I have multiple oxygen over here. I have 2 plus 1, which is 3. So what I'm going to do is sometimes when you have an odd number of oxygen or an odd number of something in a compound, you want to try and maybe make it even by putting a 2 in front of it to try and make something happen so you can finish balancing the problem. So this 2 goes to the nitrogen. So I'm going to put a 2 here to balance the nitrogen. Then that gave me 2 oxygen here, plus these 2 is 4 oxygen on the left side. 2 times 2 is 4 oxygen on the right. My coefficients will be 2, 1, 2. Let's look at number 7. We have an iron on each side. 2 chlorine on the left, 3 chlorine on the right. Lowest common multiple of 2 and 3 is 6. If you put a 3 here in front of Cl2, 3 times 2 will be 6 chlorine. So put a 2 in front of FeCl3. 2 times 3 will be 6 chlorine. But I now have 2 iron, so let's put a 2 in front of Fe, and I'm going to get 2, 3, 2 for my coefficients. Number 8, this is a combustion reaction. You have pure oxygen, you want to balance this last. You have a carbon on each side. Then you have 3 plus 1 is 4 hydrogen in the first compound. So I'm going to put a 2 in front of H2O because 2 times 2 will give me 4 hydrogen. Now, I have a total of 2 plus 2 oxygen, 4 oxygen on the product side. Unfortunately, oxygen is alone here. It's an odd number in CH3OH, so I'm going to put a 2 in front of it to make it even to help me balance this. That changed my carbon, so I'm going to put a 2 in front of CO2 to balance the carbon. Then that completely changed my hydrogens. 2 times 3 is 6 hydrogen plus another 2 is 8 hydrogen total in this compound alone. This coefficient now will be changed to a 4 because 4 times 2 will be 8 hydrogen. Then let's count up all the oxygen on the product side. You have 4 oxygen in this compound, another 4 here, so 4 plus 4 is 8. If I put a 3 in front of O2, 3 times 2 would be 6, plus the 2 oxygen in this compound would be 8, and now I'm done. My coefficients are, let's get this to refocus, my coefficients are 2, 3, 2, 4. Now, in the activity analysis, it says examine the equation for each reaction, add up the total number of atoms you represented before the reaction, then add up the total number of atoms represented after the reaction. How do those totals compare? Well, I was adding them up as I went, so you can go back and do that on your own. At the beginning of the semester, we observed that mass is conserved in changes. Does your answer to question 1 agree with the conservation of mass principle? You can answer this on your own. Number 3, look at the product molecule, ammonia, in reaction number 4. What does the coefficient tell us about the substance? Well, the coefficient in front of ammonia will be distributed to the N and the H in ammonia, which will change the number of atoms we have. What do the subscripts on nitrogen and hydrogen tell us about the composition of the molecule? So that tells us that we have 1 nitrogen and 3 hydrogen atoms in each molecule of ammonia. C, note that the sum of the reactant coefficients doesn't equal the sum of the product coefficients for reaction number 4, but in reaction number 2, those are equal. Explain why the sums of coefficients don't necessarily have to equal one another in a reaction. So I will have you explain that on your own.